Hi everyone, in today's video we are going to dive into an exciting data engineering project I worked on in Databricks. The focus of this tutorial is data patching, where we will walk through the process of handling missing or incorrect data using Databricks, PySpark and Azure Kusto. So let's get started. This is the notebook that we will be working on with today, and the goal of this project is to clean and patch telemetry data from IoT sensors. We will be using various tools like PySpark for data transformation and Azure Kusto for querying telemetry data. Okay. To begin, we first set up the environment. This %run command loads global variables and the library imports that restarts the Python session. In the cell 4, we are importing all the necessary libraries, including PySpark, Azure Kusto, some utility functions. These libraries will help us connect to Kusto database and manipulate the telemetry data for patching. Next, we are basically defining query telemetry function that queries the telemetry data from Azure Kusto. This function takes in parameters like table name, sensor ID, columns, and the start and end date. Using these, we filter the data and return it as a pandas data frame. Before diving deeper, we restart the Python session and in Databricks to ensure that we have a clean session and avoid any conflicts with libraries or variables from the previous run. Now that we can move on to the core of the patching process, which involves PySpark transformations. We will use PySpark functions to filter and patch any missing current or current data in dataset. There we also define transformations like adding new columns, filter rows based on conditions, and aggregating results. Now let's explore the heart of any data engineering project, which is the data transformations. In these sections, I will walk you through how we apply PySpark transformations to clean and patch our telemetry data, ensuring that the data is accurate and ready for analysis. So if we go down here, the first step in any data transformation process is loading the raw data into a data frame. And here we use Spark SQL method to ingest the data into a distributed data frame. The goal here is to explore the raw data and identify any missing or corrupt entries which need patching. Once the data is loaded, we need to identify the missing or corrupt values in PySpark. For that, we can use functions like isNull or nan to find these problematic records. And as you can see in this scenario, where we are basically to find whether there is nulls in this column AP production kilowatt hour. This basically is a crucial step because incomplete data can lead to inaccuracies in further analysis. In some cases, we might need to add new columns to track the patching process. So, for instance, we are creating a status column to mark whether the data was patched or not, and also whether we need that particular record to be patched or not. And additionally, we can create calculated fields based on these existing columns, such as calculating total production from multiple metrics. The when function is used to create conditional logic in PySpark. This example tags records where production values are not coming in and they are marked as completely lost, or they can be marked as the last communication and comes back, so communications coming back. Another powerful transformation technique is using Windows function. For example, we can compute rolling averages or cumulative totals over time for each sensor. This is very useful in analyzing trends or detecting anomalies in the telemetry data. Basically, this transformation uses PySpark's Windows function to calculate a running total of AP production for each sensor over time. It's useful in the time series data analysis. Filtering is one of the most common transformations in data pipelines. For example, we might want to limit our data to the last 30 days of telemetry records, or our only focus is on the sensor IDs. Then once filtered, we can aggregate the data to get insights like total production per sensor, per day, or per site. So for example, this condition, it basically filters the data based on the sensor, the start date of the last communication, and so basically the last communication date and the date when the communications came back. Finally, we might need to enrich the telemetry data by joining it with other data sources, such as metadata about each sensor. In this example, we join the cleaned and patched data with the sensor information table to bring additional fields like, so here we are joining on asset identifier to row number, right? And we are selecting these additional columns like start date, end date, and bringing it into our data set. So these are just some of the most common data transformation techniques used in Databricks. By the end of this process, we have cleaned, patched, and transformed our telemetry data into a usable form for analysis or reporting. Stay tuned for the next section where we will dive into how to monitor and optimize the pipeline for performance. After performing the necessary transformations, we joined the patched telemetry data back with the original data set. And basically, this updates the incorrect or missing values, and this ensures that we have a clean and accurate data set for further analysis and reporting. And that's how you can patch telemetry data in Databricks using PySpark. I hope this tutorial helped you understand how to handle missing data and keep your datasets clean for downstream processes. Don't forget to subscribe and leave a comment if you have any questions or suggestions for future videos. See you next time.